It is a real pleasure to see such a diverse group of people joining us today for our study launches. My name is Amara. I work as an energy and climate researcher at PRIED. PRIED is a think tank that is based in Islamabad, and we work on advocacy, mobilization, research in the domain of energy, climate, and environment, as well as social structuring. And we also have a very strong media presence. So globally, there is a very strong consensus that electrification and sector coupling are the central pillars of credible net zero pathways. And electrification has increasingly become not only a decarbonization strategy, but also a pathway towards greater energy security, system efficiency, and even long-term economic competitiveness. And Pakistan's case is a very good example in this context because the country is currently navigating a period of significant stress in the gas sector. And alongside rising electricity system challenges and a very rapid bottom-up solarization or solar uptake across the households and the industry, these parallel trends are beginning to reshape the energy consumption patterns in Pakistan, and often in ways that are faster than the formal planning processes and the policies. So it raises very important strategic questions that if part of the system are already beginning to shift, how should Pakistan think about electrification in a deliberate, economically grounded, and system-aware manner? So, and that is exactly what motivated these two studies that we're going to be presenting today. And these two complementary pieces of work, one is focused on residential electrification and the other one on industrial electrification in Pakistan. So across both these sectors, our objective was not simply to advocate for electrification in the abstract. Rather, we wanted to understand where electrification makes economic sense, where constraints remain binding, and how the transition might need to be sequenced, and what this implies for policy planning and market design in Pakistan. So the residential electrification sector study, which was carried out by Agora, our partner organization, with the LUMS Energy Institute, which was inaugurated in November 2018, and it is a think tank focused on promoting interdisciplinary research and capacity building in power and energy planning, renewable technologies, and grid modernization. So what they did was they looked at fully transitioning household gas appliances to electric alternatives by 2050 against a business as usual pathway. And they found that it could generate around US $23.8 billion in cumulative fuel import savings and reduce nearly 108 million tons of carbon emissions across the same period. Our second study for the industrial electrification, conducted by Agora in collaboration with PRIED, or the Policy Research Institute for Equitable Development, showed that electrifying processes in the industry could reduce Pakistan's industrial emissions by up to 50% by mid-century, and also deliver energy savings of more than 36% compared to current trajectories. So with these interesting insights, we are going to look at the agenda for today. First, we're going to have a presentation from the LUMS Energy Institute on the reconfiguration of traditional gas appliances in the residential sector, and then PRIED will be presenting the findings from our industrial electrification study. And then after that, we will have a panel discussion. We have most of our panelists online, and we have Dr. Usama here with us as well in person. So I'm going to hand over the mic to Mr. Huzaifa Kazmi, who is the lead energy and environment specialist at LUMS Energy Institute, to present the findings of their study. Huzaifa, over to you.
Thank you, so. So my name is Mohammad Huzaifa Kazmi. Today, it has been a very great honor and privilege to present this study with all of the stakeholders within the city, within the country, and across in Germany and in European countries and in other parts of the world. So this study is the reconfiguration of the traditional gas appliances in residential sector of Pakistan. So for decades, natural gas has been the backbone of Pakistan's residential energy sector. It has been discovered back in 1950s, and after that, the most of the economic sectors of the Pakistan has been transitioned to the gas for its economic activity. Since then, it has powered our kitchens, heated our homes, and supported daily life across millions of households. However, we now stand at a very critical and turning point. Pakistan domestic gas reserves are declining rapidly. Import dependence is increasing, and every winter, households across country face severe shortages and rising costs. At the same time, our electricity system faces very different challenges. In our electricity system, we have the surplus capacity, generation capacity that often remains underutilized, especially in the winter months. So this mismatch between the gas shortages and power surplus presents both challenge as well as the opportunity. So this study was undertaken to answer a fundamental question. Can residential electrification provide Pakistan with a sustainable, affordable, and future-ready alternative to gas? So through this detailed data analysis that we have done in our study, household level modeling, market assessment, and scenario simulations, we explored whether transition from gas-based appliances to electric alternatives could reduce cost, improve energy security for the country, lower emissions, and improve environmental situation in the country. So with this context, I would like to take you through the key insights from our study, starting with an overview of Pakistan's current gas sector challenges and why residential electrification is emerging as a logical and necessary solution. So Pakistan residential gas depends on is no longer sustainable. As I have mentioned, back in 50s, we have discovered our natural gas reserves in the country. And after that, major economic activity of the Pakistan has been transitioned to the gas. Um, One of the major sectors of consumption sector for the gas is residential sector, but it is no longer sustainable. So the natural gas has been a backbone of Pakistan residential energy system, but it's mounting a pressure that is threatening its foundation. Our domestic reserves are declining at 8.6% at 8.6% annually. And according to the Ministry of Petroleum and Energy, it has been reported that we have only 10 to 12 years, stretched to 15 years at most, at our current extraction rate, if no major new discoveries will happen in the coming years. As you can see in the graph on the right side, you have seen that since 2015, Pakistan has been a significant importer of LNG. Currently, only 75% of the demand is met by the indigenous gas production, and rest of the 25% was met by the LNG imports. So back in 2015, Pakistan has contracted with the Qatar for its LNG for its domestic demand for the power sector, especially for the power sector at that time. But later on in the recent years, because the increase in demand in the residential sector, this LNG is also routed towards the residential sector as well. The cost of this LNG that was the long-term cost of this LNG, it was $10 to $12 per MMBTU, as compared to $4 to $5 per MMBTU for the indigenous gas, which cost around $4 billion annually to the Pakistan import bill. So this rising LNG dependence increase exposure to volatile spot markets. In winter season, Pakistan demands rises. So we have to procure the spot LNG terminals in those seasons. And in those seasons, this price goes 2 to 3 times, $25 to $30 per MMBTU. So it also put a pressure on our foreign exchange. So this chronic gas shortage trigger routine winter load shedding when demand peaks, creating a permanent feature of the Pakistan seasonal energy security challenge. So another thing is the fiscal unsustainability in the gas sector, which is deepening due to the system inefficiencies. Currently, Pakistan has the two state-owned distribution companies that everyone knows. One is the Southern Gas Company, and another one is the Northern Gas Company, SUI Northern Gas Company. During the past many years, many decades, they have many structural problems. They have high technical losses. They have weak billing systems. And they have very low recovery rates. And the tariffs that fail to recover the operational costs. We have seen the highly subsidized tariff structure in the residential sector, which is cross-subsidized by with the industries. So the system losses are significant. The unaccounted for gas losses in Pakistan network far exceed global standards. It is 16.2% for the Southern Gas Company and around 10% in Northern Gas Company. And these percentages get lowered during the past few years. So this UFG losses translate into the 2 billion rupees with the per person increase in this network losses. Another one is these artificially or subsidized low residential tariffs weaken the price signals. So this encourages inefficient use pattern across all of the residential sectors, which accelerates that depletion of a already scarce national resource. So gas sector liabilities, you can say the circular debt of the gas sector has now exceeded to 3 trillion because of these network losses, delayed payments, and non-reflective tariffs. So why residential gas electrification is the logical solution now? The one is that around these problems, when we see in the gas sector, the residential sector is one of the largest consumer of the gas beside power sector and other industries and fertilizer. Power sector is at 24 and domestic sector is around 36% share annually. Another problem, if we see that in the power sector, we see a problem as well as the opportunity, is that power sector has a substantial unused capacity. We have seen in the past 3 years in the graph, you see in the graph on the left side, you see since 2021 till 2024, we have seen that our surplus capacity has increased from 30% to 50%. So in last fiscal year, it's the Pakistan generation capacity was 250 terawatt hour, whereas has only used only half of it. So, but beside that, every winter Pakistan gas system collapses as the residential gas demand triples because of the heating load. And so while around the same time, same winter time, the power demand drops and leaving more than 45% of the headroom, or you can say idle capacity, in its idle generation capacity. So this, if you see this graph shows both the electricity and gas sector, and you see that during the winter season, the electricity demand drops down because of because of the consumer is not more utilizing the cooling load in the residential sector. Now, whereas because of the winter season, the heating demand increases, so as well as the utilization of gas also increased. So these winter months are shown an opportunity as well as the challenge for both the gas and electricity sector. So this sharp seasonal mismatch between gas and electricity provides and present a perfect swap opportunity. So this seasonal mismatch can create opportunity to shift this heating load to the electric grid without requiring new generation capacity. If we see that during the winter, heating forces low-income households, especially low-income households, into the unaffordable tariff slab. I have mentioned previously the Pakistan has a very high cross-subsidized residential sector in the past years, but recently um, uh, you can say past from the since past 1 to 2 years, they started to raise the prices of the residential sector. But still, the tariff of the tariff of the residential sector is not the at par, or you can say the weighted average cost of gas across all sectors. So if you see on the graph on the left hand side, you see and one more thing I would like to add, that the Pakistan tariff structure tariff is a slab-based tariff. We have a slab-based tariff structure in Pakistan. So most of the low-income households remain in the slab one, but because of the increase in the heating load, these you can see in the graph that these the slab 2, slab 3, and slab 4 increases, and all of these consumers have shifted to the higher slab. So the Pakistan residential gas follow a step structure with lower rates for the initial consumption and escalation rates for the subsequent slabs. So approximately 68% of the households are pushed into the higher slabs during these winter season. That create a winter heating turns gas into an unaffordable energy source for millions of middle and low income household communities. So now the study objectives and the methodology. So in this study, we have seen the cost benefit and macroeconomic impact of this transition from residential gas to electric using a data-driven scenario modeling. So in this analysis, we combines the household consumption data with the market level appliances comparison to model electrification scenarios and assess the impacts on Pakistan energy sector and economy. We have seen this study across three main objectives. First, we have evaluated the cost benefit and macroeconomic impact of transitioning from gas to electric and renewable alternatives. Another one is assess system readiness for electrification. And third one is to develop a phased and actionable pathway for near, medium, and long term. So we have a staged analytical approach. In the first one is the residential gas demand profiling, in which we have seen to analyze the household gas consumption data, establish the seasonal demand pattern, and determine household income based on consumption patterns. Then we have carried out the detailed and in-depth market assessment for electric appliances as well as the gas appliances in the market, and identify suitable electric appliances available in market, compile retail prices, their operation and maintenance cost, and efficiency parameter for each technology. Then after that, we have seen the economics of household electrification, the affordability-driven we have constructed a affordability-driven electrification bundles based on the income group, estimate their capex, opex, and life cycle cost assessment. Then the scenario modeling we take place. We constructed three scenarios. One is the business as usual, then partial and full electrification scenario, and then assess economic implications across all of these three pathways. And in the and last of it is the power system impact analysis. See how the power system readiness and seasonal load substitution, and then we propose the policy recommendation for through the phased implementation roadmap. So first of all, is that this we have divided how divided this. We have created this electrification bundles based on the income class. So have you seen that we have divided into three income class: low income, middle income, and upper income class, and see which are the potential appliances would be suitable for their respective income class. So the cost of residential electrification estimation is calculated by estimating the capital and operating and life cycle cost for income-based electrification bundles. We have seen in the low income class, the cooking is hot plate and resistive and infrared based burners. And the space heating is quartz heater and fan heaters, mostly available in our market, and the instant tankless water heating system. In the middle, the cooking goes to the induction cooktops. The space heating is for the air source heat pumps, but less than or equal to 1 ton. and the instant tankless or low storage water heaters. Uh, and then in the upper middle income class, the induction cooktops or the hybrid induction cooktop and the air source heat pumps. These air source heat pumps are otherwise commonly known as inverter air conditioners in Pakistan are commonly available, and a lot of Chinese companies are already there in market. So the next one is the market assessment and economics of the household transition. So we have done a very comprehensive market analysis of both gas and as well as the electric appliances available in market, and we have seen that the gas stoves is commonly the same gas stoves are available in the market with the retail cost of up to 10,000 rupees, starting from 2 to 3,000 rupees, and their operating cost is very low, but they and as well as their efficiency. So gas stoves are 3 to 6 times cheaper than their electric options in parallel, but they typically operate at a very low efficiency, as you have seen in the 45%. And this 45 or 50% efficiency is for the new gas stoves. For the old gas stove that has been working in our kitchens for the past 15 to 20, 25 years, their efficiencies drop significantly. In the water heating technology, the market is already tuned to the alternate electric appliances. We have a huge number of instant geysers and storage geysers available in market. The efficiency of electric appliances are of electric heating appliances are much higher, but the costs are not much variable as compared to the gas ones. And the space heating is the most expensive alternative appliance, electric appliance in market. We have seen the air source heat pumps. It ranges from 100,000 Pakistani rupees to 250,000, 300,000 Pakistani rupees, but the efficiency is way much higher than its alternatives. Now then we have used this market assessment and club it with the income-based electrification bundles that we have seen. So gas-based appliances have lower upfront cost across all income group, as you have seen in this graph, making them 3 to 4 times more affordable, except only for the water heating appliance. The largest capital cost appears is the air source heat pumps. Uh, which could be a significant barrier for the adoption, but because of the integration, the coming of new Chinese market, new Chinese air source heat pump appliances, the prices of the air source heat pumps are going down. So this upfront affordability could therefore influence this constant shift to electric appliances. On the operational cost side, electric appliances are way much lower cost across all income groups and all and use cases because of their high efficiency. So for the space heating, gas-based system cost roughly 3 to 4 times more to operate than electric alternatives across all groups. So overall, this electrification delivers operational cost saving of 50 to 70% across all income groups. And finally, we have seen the lifetime cost analysis of the across three configurations. First one is the integrated solar, in which the solar plus grid through net metering. Second one is the grid only cost analysis, and third one is the gas only. So in the grid only and integrated solar use for the same electrification bundle across income group. However, in the integrated solar, we have used the 3 kilowatt net metering for the low income class and 4 kilowatt system for the high income class for only these use cases, not the entire use cases of all appliances in a household. And for the gas space, there are two typical appliance. We have two scenarios. One is for the instant water heater, and another one is for the storage water heater. And we have seen from this that the grid only doubles the gas. In the grid is almost 2 times as compared to the gas one. So under current price and tariffs, only you can say the solar electrification is both fossil free and cost competitive. This shows that the grid needs tariff reforms to make this electrification viable and increase their demand and revenues. So in this scenario modeling, we have seen three scenarios. One is business as usual, in which we have seen the continuous trend of the gas use. Second scenario B is the space, the electrification of the space and water heating. Since we have seen that there are there are a lot of appliances for the space and water heating are available. So, and the third one is the full electrification, in which the all end uses are electrified. So we have seen this macroeconomic gains. This is a summarized table which shows the macroeconomic gains in the business as usual scenario. The gas demand is around 300 billion cubic feet per year, which drops down to 190 in the scenario B, which reduce around 37% of our gas consumption in this scenario B, and 100% in the full electrification scenario. The increased electricity demand when this scenario B will be achieved is 12 terawatt hour and 37 terawatt hour in the full electrification case. And the import bill saving is 1.67 billion US dollar per year when the scenario B will be achieved, and is 3.6 around 3.6 billion USD per year in scenario C. The emission reduction similar is the 6 million ton CO2 emission per year in scenario B and 16 in C. And we have seen that the utility also improved their cash flow. Currently, the utilities make around 2 trillion Pakistani rupees per year. But with this electrification, if all of the electrification is on the grid, then they have the opportunity to generate 380 billion Pakistan rupees per year, and in case of full electrification, it will be 1160 billion Pakistani rupees per year. So we have developed, so for to achieve all of this, we need to develop the implementation roadmap, phase-wise implementation roadmap, which provide the opportunity for both gas and power sector to get ready for this transitioning. So we have developed three phases. The phase one is the 5-year plan with 25 to 30. Phase two is from 2030 to 40, is called the scaling phase. And the last one is the full transition phase from 2040 to 2050. In the table, you can see that the this shifting to full electrification requires sequencing the transition over the realistic time frame. So the space and water heating are the primary drivers of this winter gas demand spike. So prioritizing heating electrification could deliver immediate relief to gas system by targeting seasonal gas demand peaks. So as you have seen, as you are saying that in the first two phases, we have focused on much more focused on the transitioning of the heating sector as compared to the cooking one. So cooking electrification can be scaled later as the market penetration improves and the behavioral acceptance increases, because it will be the most hard sector to transition, this cooking one. So, if you see the impact on the power sector, the overall impact on the power sector is a steady and gradual transition from gas to electricity in the residential sector can enable a manageable demand growth in the initial phase. In phase one, the transition of heating appliances and cooking plus generation capacity that we already have, and particularly during the winter months. And in the phase two, as the electrification expands, the winter electricity use increases, and this narrows the summer and winter load gap and improving the capacity utilization. And during the last phase, the electrification remains technically feasible if it is supported through this proactive system planning and infrastructure planning, which include the demand side management, flexible dispatch, distributed solar integration, and potential generation addition if needed. So yeah, you can see that this purple line is the demand forecasted demand in by the end of the phase one without transition. This without transition demand is obtained from the integrated generation and expansion planning team working for the planning of the Pakistan power sector. So if we add this, if we follow this this implementation plan, we have seen that the winter demand rises from 9.7 terawatt hour to 12 terawatt hour, but the summer load more or less remains largely unchanged, reflecting that only slight change in electrification transition rate. But by the end of the phase two in 2040, you can see in the graph that the demand in both winter and summers increases. So in summer it hits 33 terawatt hour as compared to 30, but in winters the demand reaches up to 27 terawatt hour as compared to 15 terawatt hour. So this shift results in a slightly more balanced demand profile across seasons, enhancing the system efficiencies. And by the mid of the third phase, um, we have seen that the winter demand reaches to 34 terawatt hour, whereas the summer demand reaches to 43 terawatt hour, and winter demand reaches to 34 terawatt hour. So this electrification further narrows the seasonal demand gap by 60 to 65%. So by phase three, electrification remains technically feasible, as I mentioned, but if it is supported through the proactive system planning throughout these years. So I have already discussed this slide. I just mentioned mention this only the grid capacity utilization initial phase is easily absorbed by the existing idle winter capacity, and this can be carried out till the mid of the second phase. But after that, we will have to see that how the power sector planning under this transition plan. And in the last, we have prepared some recommendation for this residential electrification action plan. So during the first phase, which is the enable and de-risk, we have some major the major recommendation for the federal. One is the tariff, the restructuring of tariff. Another one is apply energy only tariffs to this incremental winter electric heating demand, and rebate the capacity charges. Currently, Pakistan, the power sector tariff has two components. Everyone knows that the one is the capacity payment, another one is the energy payment. So we are suggesting that the apply only energy only tariff to the incremental load because of this transitioning load. So integrate this residential electrification in grid expansion plan and implement no new gas connection rule for residential buildings and housing scheme starting 2026. On on the provincial side, we recommend that we have to do the pilots for cooking, combine the rooftop solar with the appliance electrification through concessional and microfinancing and targeted appliance support to move provincial taxes, and especially the aware. In the second phase, in the lock-in, we have to reform gas pricing by reducing subsidies and aligning tariffs towards the weighted average cost of gas, which will truly reflect the true cost of gas system. So prioritize early upgrades for the power sector to make the consistent to ensure the consistent supply of electricity, and establish national electrification fund with the blended finance mechanism, and begin managing phase down of this residential gas connection and appliance sale. This would be very important during this phase. And in parallel, at the provincial level, a large retrofitting program should be introduced at urban and public housing, and expand workforce training for electric appliancing retrofits and solar integration, and also design the income and tenure sensitive support scheme would be justified. So the last one is the last phase is the complete and manage is the complete the phase out of the gas and the complete transition towards electricity. So at that point, it is very important to look at and manage the gas network, repurpose it, these stranded asset, and estimate the risk that we will be having. And the align the electrification outcomes with the net zero targets and our NDC's commitments and our just transition frameworks. And on the provincial end, ensure this inclusive households coverage, which include vulnerable, informal, underserved, urban, peri-urban, and rural, all of the communities, and maintain this long-term enforcement, safety, and quality. The quality and is very important for the energy efficiency. So this monitor performance and affordability and service quality. So so this pathway forward requires this. So this is the key findings we have seen in our study. The modernization household energy use in Pakistan through the electrification can lower cost, strengthen energy security, and improve system efficiency. So the full electrification households by 2050 can deliver 24 billion dollars in fuel import savings relative to current trajectory, and also avoid 108 million tons of carbon emissions, and also provide the opportunity for the power sector to increase their revenues. So the widespread adoption of electric cooking and heating requires an integrated institutional architecture that makes the grid connected solutions are economically viable. So, and in the last, a phase electrification strategy can convert future demand growth into a planning advantage, because without planning, without planning, if we go, now we will go into another, we will see another problem. So prioritizing the electrification heating system between now and 2040, and then gradual transition to full electrification by 2040 would allow a sufficient time for the grid modernization and smooth integrate new household electricity load profiles. So thank you. So this pathway forward requires a collaboration across all stakeholders, include the policy makers to create enable regulation, industry to provide affordable technologies, financial institution to support this accessible financing, and the community and the society to embrace this new the energy practices. So thank you all for your time, attention, and the presence today. Thank you so much.
We have another presentation and then we'll go for the Q&A. Thank you so much, Josefa. And I think to see a replication of Pakistan's solarization trend, maybe we have to make a very strong economic case. And I don't see that happening right now because I don't believe the appliances are that cheap, right? So we're going to move to the industrial electrification part of the study, and I would like to invite our senior energy researcher, Mr. Manzoor Ahmed Alizai, to present PRIED and Agora's findings.
Thank you, Amara. Since Zafar has already explained the overview of the gas sector and the need to electrify to solve our dual crisis of the gas sector as well as the power sector, I'll just focus on the industrial electrification side. So what we looked at was the electrification of the industrial end use. This is the GHG emission profile of the industrial sector in Pakistan. So if you zoom in on the industrial emissions share, so there are basically emissions arise from two basically industrial processes. One is the industrial combustion, which is used like for energy generation, and the second is the industrial processes. Industrial consumption constitute the highest share as far as emission is concerned. Similarly, if you look at the industrial landscape in terms of emissions, so cement contributes the highest. Second, it's textile, fertilizer, and so on and so forth. This is the mapping of the industrial processes based on using gas as a fuel source. It is particularly important to identify the processes or gas-based processes, and then based on that, you would identify an electric alternatives for the electrification. So these are some of the processes in the industrial sector that we identified for electrification. This is the general industrial landscape of Pakistan, where industries is located. Most of these industries are in the uh, situated in the Punjab, central Punjab, and Sindh region. It is also particularly important in terms of grid reinforcements and grid feasibility assessments, that you can focus on the industrial zones or industrial areas, etc. So broadly speaking, we had three major objectives. One was to map the industrial gas use by process and temperature and identify their feasible electric alternatives. Second was to model scenarios uh, to assess the environmental, economic, and financial benefits of replacing gas with the grid electricity or on-site solar PV system. And the third was to analyze the grid feasibility for the industrial electrification. Based on the market assessment, we have also mapped the electric alternatives against the gas-based equipments, and then we had categorized them in terms of technology readiness for Pakistan. Uh, Based on our analysis, most of these electric alternatives are moderate to high technology readiness in Pakistan, especially for the low temperature industries. So, in industrial electrification, the basic idea is if a industrial process is in a low temperature bandwidth, it is somewhat easier to electrify. So we have categorized these individual industrial processes into low, medium, and high temperature bandwidth, and then assess that if it's feasible to electrify in the short term, medium term, or long term. And it is also pertinent to mention here that as a decarbonization strategy, um, electrification is not just the answer. Sometimes the electrification itself is not feasible, and then you have to move towards the other green energy resources like hydrogen, and they are specifically for hard to abate sectors. So once we identified the gas-based processes, we carried out these cost-benefit analysis based on their power ratings and whether it will be feasible to electrify with the grid electricity, or do we need and how much could the solar PV systems impact our economic assessments of these technologies. So starting with the food industry, so our analysis shows that food industry offers the electrification potential in short to medium term. I won't go into the details, but all of these are mentioned in these the assumption sets and the figures as well. So based on that, provides a cost savings of 63% if you integrate solar with the standard food industry, as well as a payback period of 2.2 years. Secondly, paper and pulp industry, it's offers a strong electrification potential in the midterm, and it could unlock 95% cost savings when you integrate it with the solar PV system, with the payback period of 4.5 years. Um, Third was the textile industry. Textile, like most of the our GDP, it's the textile industry contributes the highest in terms of our GDP. And most of these processes of textile industry are in the low to medium temperature range. So it has a high benefit to cost ratio if we electrify these particular industry in the phase wise approach, or in the short term. So um, so based on that, if you integrate solar PV system, it will have a payback period of 6.3 years and benefit to cost ratio of 1.7. Fourth one is the fertilizer industry. Fertilizer itself is a hard to abate sector. The almost 74% of the gas being used in the industrial sector is a feedstock for the industrial processes. But even if you electrify its low thermal like processes, you would have an energy savings, but you won't have a good economic return on your investments. So then there are alternate measures where you can integrate hydrogen or new technologies to decarbonize. To summarize, this is the summary of our cost benefit analysis. In terms of emissions, food industry contributes the highest in terms of emission savings, followed by paper and pulp, textile, fertilizer. In terms of benefit to cost ratio, it's food, paper and pulp, textile, and fertilizer. And in terms of energy savings, you would have highest have in a paper and pulp industries, followed by food, fertilizer, and textile. So we also carried out the macroeconomic analysis of our like the cost benefit analysis as much as what we are forecasting in terms of savings. So our analysis shows that if we have a 20% savings in the energy savings, so it would impact our LNG imports, and you would have almost $1.2 billion in terms of annual energy savings, in terms of annual energy imports, and it will have an impact of 13% on their overall gas circular debt reductions. Um, Now, the second objective of study was to basically demand forecasting. Like we had to forecast the demand in case of electrification. So currently we are the final energy demand in Pakistan currently it's 231 terawatt hours. A business as usual case it would be 462, and in the electrification scenario it will be at 294.5 terawatt hours. So you would have a 36.1% energy savings if you go if you go for electrification. And similarly, if you have a electricity demand comparison overall, then obviously it would increase once you increase your electrification. So currently we are at 15.8. So in the electrification scenario, our demand would increase to 159.6 terawatt hours. In the business as usual case, it would be at 116 terawatt hours. So if we look at the demand assessment in the short term, we would have an increase in our demand by zero point 0.4 terawatt hours, as well as 19% energy savings by 2030. So we have categorized these into different time frames. So 2024 to 2030 is the short term. 2031 to 2045 is in the medium term. So the highest potential in the medium term to electrify was textile and food and beverages. So here overall you would have a 29.1% in energy savings, whereas you would increase 39, almost 40% increase in your electricity demand based on these electrification demand forecasting scenarios. And finally, in the long term, you would increase 30%, or sorry, your savings would be around 38%, and you'd have a 37.2% increase in your electrification demand. And this ranges from 2046 to 2050. Finally, we also looked at the emissions. So overall, based on these electrification, our natural gas demand would reduce by 74%. And similarly, our emission reduction would be around 52% because of these electrification or based on our estimates. Third was objective was to analyze if we have a grid feasibility assessment, if our grid is able to sustain this increased electrification load. So this is the basic integrative generation capacity expansion plan. So currently we have a surplus capacity based on these project horizons till 2035. We will have almost around 20,000 megawatt of surplus capacity. So it was basically to assess the resource adequacy. Do we have room on the generation side that we can leverage to electrify? So we have a surplus capacity right now. But if we compare our LEAP assessments or demand forecasting from LEAP and compare it with the IGCEP demand forecasting, so this is only the comparison of industrial demand. So if we go on this route of electrification, our demand forecast of IGSEP, we will surpass them in 2029. This and by 2050 to have a more than 15,000 difference in our demand forecasting, what we forecasted and what we have. So this it's a there is a mismatch between the future demand realities and current planning assumptions that we have. So these are only the comparison of industrial demand with that of the IGSEP demand. Similarly, if we plot the whole country's demand with the leap demand forecasting, we could see that it will by 2029, 2030, it will outpace our low and medium demand forecast. Uh, However, uh, but it is also pertinent to mention here that this demand forecasting is only factoring in the industrial electrification. So if we include in our leap analysis the industrial electrification as well as the residential electrification, it will like surpass in just 2-3 years our IGSEP's projection scenarios. Um, Finally, on the distribution side, we wanted to look at the distribution. So we have a clusters of our industrial sectors. We have certain industries or a cluster of industries in certain distribution companies. So we wanted to like assess the distribution infrastructure. Yes, we do know that there is a need to do a detailed load flow analysis of our grid infrastructure, especially around these industrial economic zones that can highlight like how can we like reinforce our grid to integrate this additional electrification demand. So as far as transformers capacities are concerned, most of these transformers have a uh, overcapacity issues, but there are still issues of grid congestion, etc. And there are like numerous trippings going on, which is like somewhere it's greater than 300 per day. These issues impact these in the end power quality and supply continuity and constraint and worsen the integration. So it's not a there is a like broader uh, uh, assessment that we must carry it out in terms of load flow analysis and identify the the areas that we can like intervene in to so that we can integrate the higher industrial load in the distribution sector. Finally, we also gave the transition framework. So currently we have these barriers, and these barriers presents opportunities as well. So we have a policy and regulatory gaps, financial constraints, uh, infrastructure limitations, so on and so forth. But these barriers also like present us with the opportunities that like we need to have a policy coherence. We have to explore the new avenues for credit lines, etc. Uh, so based on that, we presented this transition framework in which we have these strategies as well as their corresponding actions that we should take in the short term, medium term, and long term. And it's mostly focused on the policy alignment. Like for example, you have different NDCs, different plans, so it all must also like contribute to each other. Simultaneously, we don't have any electrification targets, so we must also incorporate these into our commitments. And similarly, we have to leverage on our uh, surplus generation potential that we have, as well as the address the issues of grid underutilization, etc. So these are some of the strategies and their corresponding action that we have listed here. Key findings of our research was that 50% emissions potential to save 50% of our emissions. Secondly, we should target the low to medium temperature applications in industries for earlier electrification, and then like go above. Uh, Third was the supporting tariffs reforms, financial incentives for appliances, and regulatory reforms to modernize power grids. And number fourth was the national strategy sequence techno-economic readiness that can position electrification at the core of Pakistan's energy transition and industrial modernization. Uh, so yeah, so that's it from my side. Thank you.
Thank you so much, Manzoor. And I think it's high time we shift away from dirty fossil fuels to cleaner, renewable technologies and energies that we have a plethora of in Pakistan. And especially with the advent of in the imposition of the CBAM and other similar carbon border mechanisms, our industries need to be very competitive. We are going to move to a short question and answer round, and then we will go to the panel discussion. So please, you can feel free to drop your question in the chat box or come online and ask the question. And for people who are here in person, please introduce yourself and you can pose your question then.
Yes, this is Shahid Mahmood. I'm CEO of the big generation company, Genco Holding Limited. My first question is actually that while the approach seems to be okay, but consumers will not adopt it unless they find the electric price, unless they find it cheaper to have electrical appliances. So have you done any analysis, for example, on the geyser with the current price, whether it's going to be cheaper to have a geyser on electricity or on gas? So that's the first thing I think you will have to address.
Uh, excuse me, can you ask the question again? I can't hear you because
Okay.
hold the mic. Yeah, now I can hear you. Please, yeah.
Okay. Okay. So my question is that consumers are only going to adopt replacement of gas appliances by electrical appliances if they find it cheaper to run like that. Based on the current high prices of electricity, especially, gas prices are also going high. Have you done an analysis how cheaper or expensive it's going to be if they shift to electrical appliances? You can say for the simple ones like a stove or even a geyser.
Thank you. So we have done the life cycle cost assessment across three different configurations. So one is the grid only, another one is the solar only, and third one is the business as usual that we are doing, the gas ones. So you are absolutely right that the grid prices are extremely high for the residential sector. And the prices of the per unit cost of the electricity is around 50 rupees, including tax, 50 to 60 rupees. So that doesn't make any sense. We can't transition at that rate. So that's why we have suggested that the tariff restructuring is very important at this point. And for our initial phase, the implementation framework in our initial phase one for the next 5 years, we have suggested that you can only charge the energy tariff, which is around 8 to 12 rupees per unit. So 8 to 12 rupees is you can say competitive with the solar prices, with the gas prices. Currently, if we see the tariff, the electricity tariff, the existing electricity tariff, the life cycle cost of the electric appliances would be double as compared to the gas prices that we are paying. But from the if we go to the solar, the prices of the operational prices goes down to half as compared to the gas ones. So from that assessment, from that analysis, we have suggested that for the initial phase, the government should be restructuring the tariff at least for the increased consumption. After this transitioning, we should only charge the energy tariff, not the capacity component. At least we can generate new revenues and bring in new loads to the grid. Thank you.
Right, thank
Well,
you.
it's a very wishful
Yeah.
plan. I say this is impossible that government will charge only energy prices. Number one. Number two, it will be extremely difficult to find out exactly how much is the increase and how much should be energy price only, and that can only be done as long as your capacity is in excess. So if the capacity current higher capacity, perhaps it will be no more higher because within 2 3 years if the GDP growth goes on. So this project cannot go ahead. So I think we have to see really and make some calculation how expensive or how cheaper it can be, and only on the base of that people will adopt. This is what I think. Anyway.
Hello, everyone. Oh, sorry. If there are any other questions from either Huzefa or Manzoor, they would be happy to answer them.
So, Dr. Osama here. I have a question about the modeling. Like you talked about, like you got the residential gas demand profile. So my first question is how you got that one, and secondly, your approach is more like accounting-based modeling because it's considered socio-economic factors only. But if we see the Pakistani like residential sector, there are different housing sizes, like small houses, medium houses, large houses. So it's very critical whenever we are doing the demand modeling, we have to consider the sizes of the user. And secondly, how you like this is a third question, sorry. How you calculated the emissions overall, like.
Yes, thank you. So for the modeling, so you are right that we have to incorporate various socioeconomic factors to begin with. But for now, we have only considered for this study, we have only considered the energy, the consumption from the different income classes, for the low income classes and for the middle income and the high income classes. Um, uh, this how we divide the income classes, this is given, you can see in this study, it is present in the appendix of the study. But for this study, we have only seen the energy consumption, but we have also looked at the household area, the primary fuel for cooking and heating that they consume, and the appliance ownership. So we have gathered the data from the 1,000 households across the Punjab and some of the areas of KPK. And for the gas data that you were mentioning, we have gathered the data from the SNGPL, from the NTDC, and for the demand forecasted data. In my later slides, we have got that data from the IGSAP team. They have forecasted this electricity demand by 20 till 2045. So we have gathered that data from them. So for your last question, emission modeling. For the emission modeling, we have used the UNFCCC methodology. Right now I forgot the exact methodology name, but we have used the UNFCCC methodology for this calculation of this emission.
Right. Thank you so much, Josefa. You can maybe reach out to Josefa directly. He can share his
Yeah.
contact details because we need to move to our panel discussion, if that's okay.
Sorry, it's the next presentation.
Yes, we need to move to our panel discussion.
Okay, just put the question.
Okay, you can ask the question with.
Ask the question. Don't need to answer them. Just see. Maybe we can still. Sorry. Okay, just quickly, I will put two questions. You have done some analysis on the fuel saving. So please look into that, because the fuel
Yeah.
is by going electrification, you will be burning more fuel somewhere on the power plants, because the power plants, they have efficiencies ranging from 40 and some only on 60%, whereas in the gas, Efficiency is already 50 to 60%, as you have already said. So perhaps there's not going to be any fuel saving. The next is the emissions. So you may actually prevent emissions in the households, but the same electricity is produced by the power plants, which are emitting anyway. So overall, there may be no saving in emissions. So, okay, that's all.
Thank you.
Right, thank you. And just to add to that, about the electricity being generated from dirty fossil fuels, in addition to that, how do you think how easy or hard is it going to be to change people's perspectives and preferences? Because if you cannot make an economic case to make that shift, like we saw in the solarization trend, then this electrification is just going to be very difficult, especially considering the new electricity tariffs and then the net billing policy that was just implemented. And it's almost like they're discouraging solarization. So how are we going to switch to cleaner alternatives if the policy landscape is not conducive to it?
Thank you so much. So you're exactly right that I'm also always the advocate of the economic factor, that the economic factor will be the key factor that will come in place for when we ask the community or the citizens to transition toward the electricity, as in case of the solar electrification. Um, Beside that, this economic case, there is another thing for the cooking. In cooking, uh, we have seen the country is already moving toward the electric heating appliances. A lot of households have instant gas heaters and instant electric storage geysers, and as well as we have a lot of people, a lot of citizens have the air source heat pumps, or you can say inverter ACs in our country. But for the cooking, we have to shift it needs a behavioral nudge from the government, from the awareness the communities to push the people, and from the economic, as well as make them at ease that you can prepare the cuisines from the electric cooking as well. So you are right that the economic factor is the key factor for this transitioning. So that's why we have used in our analysis. We also see the integrated solar. So at the solar, a lot of people are transitioning towards the solar. They are installing the solar. So that's why we have seen that if at least those people are transitioned towards the electrification, they can make their case more more economically feasible.
Thank you so much, Josefa. And I think we have found our next campaign idea here. So we're going to move towards our panel discussion, and I'm going to quickly introduce the panelists. So we have with us in person Dr. Osama Pervez. He is Associate HOD for college at the College for Electrical and Mechanical Engineering at NAST. Then we have Mr. Engineer Asad Mahmood, sorry. He's a renowned consultant and an energy efficiency expert. We also have with us Miss Naila Saleh, who is a project manager at Agora, and from our partner organization, the Alternative Law Collective, we have Mr. Muhammad Abdul Rafi, who is a research and fossil campaigner. So my first question is going to be towards Asad Mahmood Saab. In terms of the current policy landscape, echoing the question that I asked Huzaifa, what kind of policies and initiatives should we have in place that aim for this electrification and this transition? And how is the thinking developing around the future role of gas versus electricity across key sectors in Pakistan?
Well, I think there are certain points which have to be kept in mind in terms of the transition. As you have asked, like the question in two segments, I think like the findings which have been presented are something like we can take it as an eye opener, and at certain time intervals, such nudge have been given by different development partners as well in terms of transition, because in transition we need not to look into the speed. Doesn't matter. It's the direction and discipline which really matters at the end of the day. So in terms of the transition to electrification in households or industry. So I think the first and foremost thing is going to be the tariff reforms, how the tariff reforms are going to be done. And efficiency should not be penalized, even though if you go for electrification, it might raises your electric slabs. And again, like as has been presented as well, that aspect has to be kept in mind. And with this net metering or presumers regulation modification coming in, I think behind the meter sort of appliances and that is also going to trigger the electrification mod in terms of have those people having surplus installed capacities, and they would be definitely looking into getting in return good service against efficient appliances. So that is another element which is coming up. As you can see, the distributed energy in being deployed at massive rate, and definitely for it, the best fit solution is going for electrification. But in terms of industry, the policy levers are already being set, which you can see in terms of levy which has been imposed on the captive power plants, which is forcing the industries to either partially switch, or transition go towards the transition from like in terms of medium heat ranges processes towards electrification, either through absorption chillers or through other heat pumps which are there in terms of water heating or air heating. And then this CTBCM or with this coming into function, I think people would be utilizing the best available resources, or if they are getting the choices in terms of picking cheap or efficient electricity or clean electricity, they would be definitely going towards then any saving in that would definitely or should have to be diverted towards efficient appliances or retrofitting programs. And there should be public private ventures in this retrofitting. And it is not going to happen, the grid augmentation and things, that they take time, and it has to be looked into parallel. Isolation things in isolation will not work. And then the other part which you have just mentioned, that in terms of when we talk about the grid, then all the things are only possible if in terms of electrification, if you are getting cheaper electricity, reliable electricity, and that is and financeable projects. So this triangle has to be worked out. And similarly, in terms of transition in houses, you might have seen like frugal engineering, or just like going towards EVs. EV in terms of transport is definitely there in terms of electrification, massive electrification. But again, you also see that hybrid mods are their quantity is still much more than that of the EVs as of now. So even in the houses, you can see like the market growing up, where the conventional or existing gas water heaters are being shifted into hybrid mod or slightly automated. They are not leaving the gas at all. They are applying the cylinders with the existing geysers because of their centralized structure of water distribution system. So again, the plumbers and full ecosystem has to be developed in terms of electrification. Your single phase consumers, if you are going for electrification, they have to go for 3-phase meters because of high amperages, and that triggers the tariff rate applicable on them. So it's again that sensitivity aspect also has to be looked into, if moving from A1 to A2 or TOU aspects, because long-term decisions, even industries are a bit like sort of confused at this moment, because your prices are like the government is announcing relief at one end, and on the other side, it's not really translating into relief, because some other segment pops up and adding to the taxation or and other fetching out their precious savings. So I think like that these all things have to be kept in mind, and a conclusive or all inclusive approach has to be taken, and appreciate the work carried out, and and it also has to be looked into in conjunction with the previous study which USAID has done on this electrification of appliances a couple of 2-3 years ago, and results almost match alike. And then definitely there are other variables in terms of you have PSLM data, what modifications could be done in that in their next surveys. These reports are going to give some insights to them as well. So I'll just stop over here.
Thank you so much, Asad, for such a comprehensive and in-depth answer. Um, I'm going to give the mic to Dr. Osama, and since we're talking about the economics of it all, um, both studies have highlighted that economics and system reliability are decisive for any electrification decisions that we're going to take in the residential or the industrial sector. So in Pakistan's context, if we are talking about shifting either of the demands or the gas loads towards electricity, what kinds of supportive measures are needed to create a business case for electrification, especially in this context of tariffs and upfront costs that are required for installations?
So first of all, I think so we need to work on the tariff side. We need to introduce the flexible tariff mechanism. We have the time of use TOU tariff in residential sectors, but we also need to consider this flexible tariff mechanism in which we can allocate the benchmark, like this industry is using this one and for this 1 year, and if they use the excessive one above that benchmark, you can give them the like lower rates, and we can also consider like flexible load, which is increasing because we are doing electrification in different segments. And this can also be overcome by using smart meters. Like if we introduce the smart meters, we can see where is the peak loads and where are the flexible loads. And we can shift our industrial users toward flexible tariff mechanism. This can be one of the way out because we already have like capacity payment issues in Pakistan. So what we can do is shift that not usable electricity towards these flexible loads, and we can also overcome the financial crisis we are facing in our power crisis, sector. And secondly, for electrification in industries, we need to introduce different schemes upfront, like subsidies. Even if you can know, like recently, Prime Minister of Pakistan has approved like fan replacement policy by NICA, and in that one we need to like we can replace our old fans with the new one, inverter fans, and they are also funding it through some financial mechanism through banking. So we can also introduce these type of schemes, like if any industry electrify it, and we can use those financial mechanism through banking, so we can introduce those. And secondly, we also need to keep an eye, like we are electrifying, so we also need to ensure the quality of the products which are being introduced to electrify. If we are like implementing inefficient electrification techniques, so it will also be not helpful to our economy. And like the last one is reliability, because most of the people or even in Pakistan feel like even our electric grid is not that much reliable. So that's why there will be a little bit hesitant to move towards the electrification side. So we need also to work towards a grid efficiency, and the grid like need to invest on the grid side also. So these are some points from my side.
Right. Thank you so much, Dr. Osama. So, in addition to the financial and the economic and the technical dimensions of it all, I think an important consideration beyond this is that electrification could also be constrained by a set of political economy challenges and factors. So, coming to you, Rafe, I would like to ask you, where do these political economic constraints sit, and where do you see a realistic entry point for reforms?
Hi, thank you so much. I think this is so overall, if we look at this particular question, even from the landscape of the institutional landscape and the integrated methodology, then I think there are several things that we must keep in mind whenever we talk about the electrification of the residential sector or the industrial sector. For me, like even like the criterias or the overall modeling results that have been shared, for me ultimately the touchstone is the CBDR principle, which is common but differentiated responsibility metric. That is very important. So like you talked about the political economy, but for me, political economy even is part of the major matrix that should be talked about. So like if we focus on the current drive, which is being pushed by the government and the IMF together, and the power division as well, the current drive to shift industries onto the grid, and that allow us, like if we look at that particular movement, that allows us to identify several gaps, right? And I want to raise some of the questions that will help us identify these gaps. For instance, the very first question would be, is this like a long term strategy or is just a stopgap? And secondly, like is the government making the right investments to make the grid cleaner, flexible, and respond better to the solar deployment pace in the country? And also another question would be like, what is the real motivation behind these measures? Is it just about emission reduction intensity, or does this primarily aim to like, respond to the falling grid demand and stop the rapid solar uptake in the country? So I think these are all very important questions, and unless we address these questions, we cannot really understand whether the current electrification drive is going to have a positive result on the overall problems that the country is facing, whether that is the rising circular debt problem, whether that is the grid that is still dependent on the dirty fossil fuel projects, and whether that is the IGSEP and TSEP planning, which is still focused on the large hydro projects and the larger transmission line projects, and which does not cater about the modernization and flexibility. So I think in terms of political economy, definitely there needs to be a close coordination between federation and provinces, and then several divisions. For instance, the power division, the petroleum division, the planning division, the climate department, which is now decentralized across federation and provinces, and then the NDC's targets. Unless we bring all of those actors together, and unless we make all of them speak to each other, there can't really be an electrification. All we will be doing is just repetition of the past mistakes. So for instance, even like if we look historically and we just look at the subject of the gas, we will see that there hasn't been any consistency on who is the high value user of gas. In the 1960s and 70s, we see the World Bank saying that, okay, the best high value user of gas is the power sector. And then in the next decade, it realizes, no, power sector is not the high value user. Probably the industrial sector is. And then we also see the World Bank and other major players changing hearts vis-a-vis the domestic sector. And now what we see is the current electrification drive through the captive levy. All of a sudden, industries and fertilizer are not the best users, right? And the ultimate result will be maybe the circular debt for the power sector will come down, but the circular debt for the gas sector will go up. So how do we speak well of this particular situation that we are in? So I think it is very important that we think about this question in a way that is very much integrated and looks at all the dimensions. Otherwise, maybe the emissions that we are talking about, will go down, may not be the true reality of what will happen.
Right, exactly. Good point, Rafi, that we currently need holistic planning across all departments, all ministries at the federal, provincial, and even at the local level. Because if policy planning is done at the federal level or at the national level, and they're not aware of the ground realities of the regions like Tharparkar or somewhere in Balochistan, then they cannot make a very informed and realistic policy or take any measures that could be accurately reflected there. So as Asad mentioned as well, and now Rafe, Naila, I'm going to pose this question to you about institutional architecture and the broader value chain. So if Pakistan were to move from towards a more deliberate electrification pathway, not just depending on the technology or the economics of it all, to enable this transition, where do you see the most critical gaps that need adjustments?
Yeah, thank you, Amara. I think first we all are increasingly aware that electrification is a key strategy shaping the future, not only in climate perspective, but also in terms of energy security and competitiveness. However, the key premise is that the transition to any new technology, it requires the alignment of a co-evolving mix of planning, institutional coordination, and market-enabling frameworks. And so most of my points might overlap with the early speakers, but yeah, firstly, I think Pakistan, it doesn't lack the pieces of for electrification. Rather, it lacks synchronization across the value chain. And in many countries, usually the starting point for electrification is often a very tight power system. In the case of Pakistan, interestingly, we have this structural window of an underutilized power capacity, which, at least in principle, is a good opportunity in short to medium term. And then in parallel, there is this ongoing decentralized solar momentum. So households and industries, they are already investing in distributed solar, and there's enough system headroom combined with a strong solar momentum, and so this makes a relatively easier entry point for electrification. And what needs to be assessed is how we could better use these resources that we already have. However, in parallel, what is happening in the eco space is that gas is gradually being phased down through pressure points like tariff hikes, captive power plant, phase out timelines, load shedding of gas. And there is no clearly articulated substitution pathway for household and for industry. This definitely then creates uncertainty. So when we look at the economic barriers, electricity tariffs are uncomfortably high. Also, upfront cost of switching to alternative technologies, and these are clearly very important barriers, which makes investment decisions complex for potential adopters. And then electrification also introduces a new demand dynamic, and if these are not properly anticipated and embedded in the long-term planning frameworks, then again it creates friction at the generation, transmission, and distribution edge. So all of these misalignments that we see in the present socio-technical system, these needs to be addressed, and that bridge is institutional. What is needed is an institutional architecture that aligns regulations, supportive tariffs, access to financing, and grid and distribution sector planning frameworks. And I will highlight here a few key points on institutional alignment. First, as also highlighted by the early speakers, affordability is going to be a decisive factor in determining whether and to what degree electrification would scale. So, if operating costs remain higher, then electrification will struggle to gain traction. And here, the pricing frameworks need to evolve in support of the transition. Secondly, what has also been highlighted in both studies, sequencing, it becomes absolutely critical. In global south, governments often operate under much tighter fiscal constraints, and they lack the fiscal space to heavily subsidize early electrification or fund large scale grid reinforcement. So that means that the transition design has to be more selective. And the smarter way forward is to start with the segments where the economics and system benefits are already strongest. Then funding schemes for upfront investment support will also determine the pace of electrification. If financing schemes and other incentives are not aligned with the direction of the transition, then adoption will remain patchy. And also, and this has also been stressed already, that power and distribution sector readiness is equally significant. How the grid is planned, how more granular sectoral projections in planning documents like IGSEP and TSEP are incorporated timely. So at the bulk system level, yes, there may be some more headroom in the near to medium term, but local network constraints, reliability issues, planning visibility, all these will determine how fast electrified loads can actually be absorbed. So this system level thinking is important. And ultimately, all these adjustments depend on one foundational element, that is a clear policy direction on electrification and indicative targets for electrification. So there is a clear need for action on the policy side and overall high value and use prioritization, improving economic conditions, power sector and distribution sector readiness, financing schemes, planning coordination. All these elements, if come together under a coherent action plan, then the electrification journey could be unlocked effectively.
Thank you, Naila. So I'm going to pose a question to all of our panelists, and maybe start with Dr. Osama first. Uh, there should be equity considerations when we look into any new technology, because when what we see in the solarization trend is that the urban centers, the people living in better neighborhoods like Beria Town, DHA, or in urban centers in Lahore somewhere, they electrified and solarized a lot faster compared to the rural areas. And there is a possibility that we can see a similar trend if it's coming from a policy level rather than if it's a bottom-up approach. And so how do we ensure that equity considerations are in place? Like, I know there are a few initiatives like the Clean Cook Stove initiatives. There have been a lot of distribution in Nepal and I think in Bangladesh somewhere, but in rural areas which do not have access to gas even, so, and they burn wood, firewood for cooking and heating and everything. So how do you think should be the priority order? Like, should we go towards the rural areas first, electrify them, go towards the urban centers then, and then towards the industrial, or like, how do we take this up?
Okay, thank you for the question. First of all, it's very important to have just energy transition, and it's a very important pillar of any sustainability policy reform if we introduce at any level. And secondly, if we talk about the rural areas or the urban areas, like in solar, we have more like solarization in urban areas, but if we see like in solar tube wells, agriculture sector, we have seen like solar has been a big reform, and even the Punjab government under Chief Minister Mariam Nawaz, they have also introduced some schemes in which they are also giving solar panels to like agriculture farmers. So we can also introduce the same type of schemes here. Because if we see the energy pattern across the Pakistan, we have a lot of like biomass pattern. So we can also shift that biomass pattern, which is being used mostly in areas where there is no grid, like rural areas. So what we can introduce is like we can give solar panels plus clean cooking devices like IH induction cooking scheme, or we can even finance through any like a state bank or government of like Punjab government, Punjab Bank, and these type of different schemes we can introduce even for the rural areas. So it's very important, like we have a just energy transition. It's not like only people sitting in areas where they have good economic, they are economically very strong, and we are introducing those policies only there. We also need to like catch up those people who cannot manage these type of new technologies. And secondly, if I see from the demand side, we can also need to see the hotspots of energy demand, and we can introduce these type of like electrification or fuel switching schemes using those techniques, like where there is a big demand of gas, and we can introduce electrification so we can make the gas grid more stable. And these type of schemes also can be introduced on the grid level also.
Thank you, Dr. Osama. Asad, would you like to add to that? Maybe tell us how just energy transition considerations are taken into account, especially at the policy making level, because you've been working with the government and with the other development sector organizations. So if you could shed some light on that. Asad, can you hear us? Okay, I think he's not, yeah. So maybe Rafe or Naila, if either of you can take the question.
Yeah, I think this is a very important dimension, equity. And even in the case of distributed solar PV, we see that the spatial disparities across income groups in terms of adoption level, it is very distinct. And in Pakistan and most global South countries, the difference in the economic profiles of consumers is comparatively more distinct. So to avoid this, I think equity must be embedded in the design of the transition from the outset, and this would require targeted subsidies or concessional financing schemes or grant windows for low income households. And yeah, equitable electrification should be an important pillar of electrification transition.
Rafi, over to you.
Yeah, just a few components around this. I think this is really at the very core issue before us. So even if we look at the current electrification case study, which is related to the residential sector, it mainly addresses the question of those who are living in the urban centers, right, on the network of SNGPL. And this is Punjab. Now, if you look at Punjab, Punjab is just the consumer of gas and it does not produce any gas itself, right? On the other hand, Sindh is the major producer. So I think when we want to discuss the question of equity, there are many issues that we should think about. First and foremost is who is the user? And secondly, so for instance, there are many users within the Sindh and Balochistan and KPK who don't have access to the electricity at all, right? So targeting them and prioritizing them in terms of providing them affordable energy in some form, whether it is gas or solar panels or something else, that will be very important. So yeah, I think differentiating between these geographical differentiations and also in terms of those where are the wellhead resources and who is just the user of gas because it can pay back in terms of money. So these are all very important issues. So for me, I think we should definitely focus more on those who don't have access to the electricity right now. And yeah, so starting from that, I think maybe we can address and include other areas as well.
Thank you so much, Rafe. And I'm gonna end on a very specific note. It's a personal experience. So I was traveling to Gilgit-Baltistan for an assignment, and when we visited this Aga Khan Foundation, they have this, I think, they have this institution there. And what they did was they empowered the communities, and those communities began to indigenize clean cook stoves and ovens, and they had these because they did not have access to the gas. So what they did was they used solar energy and to some extent firewood as well, but mainly solar energy. And they assembled and created those all of those instruments that they used for heating and cooking in a house. And there were a lot of people and local technicians who had the capacity to repair them even. So I think that is one model that can be replicated in other rural areas of Pakistan as well. Maybe we can get in touch with them, get the government there, and figure a way out to replicate and scale that up. So I would like to thank everyone for joining us today, all of our online participants as well as our panelists. Thank you so much for joining us and adding value to our studies and to our discussion. Have a great rest of the week and the weekend, and thank you.